section 6.2, bisectors of triangles. So section 6.2 has a lot of vocab that you've probably never heard before, other than perhaps the first one. So the first word is concurrent. And concurrent is when you are happening at the same time. So it's used outside of math class, but maybe we'll just do 3 lines here. All 3 lines exist in one place at one moment, and that place is right here. It's where they cross. It's where they intersect. And the place where they intersect is called the point of concurrency. So concurrent just means they cross. The point of concurrency is the point where they cross. So the next vocab word, circumcenter. So if you have a triangle like this, and you draw or create or see the 3 perpendicular bisectors. So roughly drawing here, here's a perpendicular bisector, and we would know because it would be perpendicular and go through the middle. The next perpendicular bisector might look something like this. Perpendicular and through the middle. And the last perpendicular bisector might look something like this. 90 degrees and through the middle. And if you were to create these on a triangle, using a compass and straight edge, or using a computer program, or maybe you're just given the picture, those 3 lines will have a point of concurrency. They will all cross at one spot, and that spot where they cross is called the circumcenter. So, why would you ever need to find the circumcenter? And it's due to the circumcenter theorem. If you have your triangle and you have the circumcenter, the special thing about the circumcenter is that it is equidistant to the vertices of the triangle. So this point right here is the same distance from all 3 corners of that triangle. This distance, and this distance will be the same. Let's give some letters here. A, B, C, D. AD will be congruent to BD, which is congruent to CD. Now the benefit of this is that it would allow you to essentially make that a radius and draw a circle perfectly around the triangle. Perfectly around triangle. So when would you ever actually need to do this? Picture if you were playing a game, and maybe it's like a game of dodgeball or something, and the balls are in the middle here, and the 3 people in the game are here. The balls, what people are racing toward, perhaps at the beginning of the game, you would want that to be equidistant from the people. So how do you find the middle of that triangle? It's using the circumcenter theorem. Now maybe, you're not going to take enough time at summer camp or whatever to calculate that, but that's what's going on. It's making the distance from those 3 points to the center all the same. Now the incenter is a similar idea, except it's taking your triangle, it's taking your triangle and it's calculating the angle bisectors this time. So there's one angle bisector, and you would know it's the angle bisector because of the congruency marks. The next angle bisector would go something like this, and you would know it's the angle bisector because of congruency marks. And the third angle bisector would look something like this. And you know it would be a bisector because of the congruency marks. And the point in the middle would be called the incenter. So it's the angle bisectors making an incenter. Now the incenter theorem is similar to the circumcenter theorem, except when you draw your angle bisectors, or they're given like maybe constructed on the computer, or it's just given to you as a picture, the incenter is not equidistant to the corners, to the vertices. It's actually equidistant to the sides of the triangle, which allows your circle that you would potentially draw to be inside the triangle instead of outside. It means that this point right here is equidistant to the sides of the triangle. Now the issue with this is that it does not mean this line here is the same as this line, which is the same as this. We actually haven't drawn the distances to sides, because remember, distance is measured perpendicular. So you would have to have perhaps a new line with a 90-degree symbol. So look for the 90-degree symbol. Those are the ones that would be the same distance. So example 1. In is the incenter of triangle ABC. Use the given information to find the indicated measure. So important things. It is the incenter. So that means this point N was created by the angle bisectors. Now, they don't show you that, but because it says incenter, that's how this point was made. And the incenter is equidistant to the sides. And the sides are going to be marked with 90-degree symbols, and you see NE, ND, and NF are going to be equal. They're going to have the same lengths. So ND and NE will be equal, so set them equal. 2x minus 5 equals negative 2x plus 7, and solve. I'm going to add 2x to both sides. 4x minus 5 equals 7. Add 5 to both sides. 4x equals 12. Divide both sides by 4, so x equals 3. Now the issue is we're actually looking for NF. And we're not told any equation for NF. But remember, all three of these are the same. So let's plug it in for ND. 2 times 3 minus 5 is 6 minus 5, which is equal to 1. So ND equals 1. So NE equals 1. So NF equals 1. Example 2, find the measure of PA. The tricky part with these is keeping the vocab straight and knowing what the picture is. The actual math of it tends to go fairly quick usually. So let's hear, what is this? We have 90-degree marks. Look, we have 90-degree marks over here also. So what else do we have? Look here. 1 tick mark, 1 tick mark. 2 tick marks, 2 tick marks. These are perpendicular bisectors, which means we have a circumcenter. which means we are equidistant from the vertices. This is the thought process you should go through. So that means PB, PC, and PA are all the same. So PA equals 13 because PB equals 13. Little to no work, it's the thought process that I want to see here. Next one, find the measure of PS. What is this a picture of? We have 90-degree angle marks, just like we did up here. But what about the bisector part? The congruencies are here. These are angle bisectors, which means this is a picture. P is an incenter, which means it is equidistant from the sides of the triangle. That means PS, PT, and PU. These three distances here are the same. So PS equals 8 because PU equaled 8. Example 4, find the measure of GE. What are these pictures of? We have the 90-degree marks, but we also have, look at that, this piece and this piece are congruent. This piece and this piece are congruent. And I'm not going to trace them because I don't want the picture to get too messy. But you see we have 3 tick marks, 3 tick marks. This is a picture of a perpendicular bisector, or of perpendicular bisectors, which means that point is a circumcenter, which means it is equidistant to the vertices. One vertex is E, one vertex is D, so it means GD and GE are the same. So GE equals 10. The last one, example 5. What is this a picture of? We have our 90-degree angle marks. Sorry, we have our perpendicular marks there. But we don't have any midpoint marks. What we do have are angle bisector marks. So this is an angle bisector, which means N is an incenter. So it is equidistant to the sides of the triangle, So NF, NE, and ND are all congruent. So what's NF? It's 2 because NE was 2. It's important that you go through this this thought process every time, because we're going to add a couple more pictures to it, which will make it more complicated, and then we will mix them all up and do lots of them together. So please, please, please go through this thought process every time. We will not be doing the constructions of this section because of compasses and straight edges. So at this point in time, you should have enough information to do the homework.